Proof of work is a consensus algorithm originally proposed by Bitcoin. It's a solution to the Byzantine generals problem mentioned previously. It's one of many algorithms that can be used to help reach consensus on a blockchain. In this video, we'll define proof of work, then discuss the details of what makes it all work. The basic idea behind proof of work is that a piece of data can be costly or time-consuming to produce, but simple for others to verify that work. In proof of work, there is an upfront cost of resources, known as work, put into generating a block's hash value. This work can easily be validated by the rest of the network to check if it was done correctly. In proof of work, each node is involved in solving a problem meant to prove they've done some required work. Having put in the time to do this work is a signal to the system that it is likely able to trust the result of the work that was done. Nodes who attempt to solve the problem are known as miners. Mining to find the solution to these problems can take a lot of computer power. These miners are constantly in a race to solve each problem as quickly as they can to build the next block. In return for their time and resources, they are paid transaction fees that come directly from the users making the transactions. They're also awarded by the network with bitcoins that are created specifically as a reward for mining the new block. These new coins that are created are the only way new coins are ever introduced to the system. Let's look further into the problem these miners are racing to solve. Miners are trying to find the knots for every new block. We covered this earlier, but here's a recap now that you have some more context on what it's for. When creating a hash for a block, not just any value will work. The system requests a very specific hash value that starts with a certain number of zeros. These extra constraints make the hash much more difficult to find. To find that value, you combine all of the block's data with this nonce to try and generate the correct hash value. Computers guess the nonce over and over until finally they come up with a value that gives us a hash that meets these constraints. Exactly why this is important might not be so clear right now, but we'll cover this in more detail when we go over mining. To help you understand what's going on a little better, let's jump into a demonstration.